Welcome to Linacs Actuator Academy video series for industrial actuators. I'm Hunter, and today we're going to talk about an I/O actuator's monitor features, one of several options configurable within the Actuator Connect configurator for Linacs I/O interface. Monitor allows you to see real-time and historic usage data for the connected actuator. This data can then be used to gain useful insights into how the actuator performs in your application. If we open the Actuator Connect configurator to the monitor option, Real-Time Charts is the first tab showing power consumption, temperature, position, etc. that can be especially valuable in the prototype phase. By hovering over a region on the live chart, you can use the scroll wheel on your mouse to zoom in and out on data. On the right side, you can find toggle switches for each parameter that you can monitor. Simply choose the data that you want to see in the graph, and even choose more than one at a time. As you can see here, there are 5 things that you can monitor: position, temperature, voltage, current, and speed in millimeters per second. By conducting actuator test runs, you're able to get an indication of how well the actuator can handle the real-world conditions it's been designed for. For example, do you have enough power, or is the power consumption constantly maxed out? Or even noticing a current spike at a particular movement that you didn't expect that can help you review the mechanical design of your application. Use the export button if you want to save the graph locally on your PC and evaluate your solution, or even compare it with other test runs. Just like we offer real-time charts, you can get real-time information about the actuator's current consumption and temperature via an analog or digital signal directly to your PLC. By using a digital output, you can define an interval for normal operation, and if the actuator detects a value outside this range, it'll send a signal to your controller. An example could be an alert if the current consumption rises above the set limit. It's up to you to decide how you want to use that information, but it could be used to raise a flag on the PLC to inform a service technician that the component is worth an inspection. As previously mentioned, you can also use analog output to monitor current consumption or temperature. In this case, you can get real-time view of the exact values presented as either a 0 to 10 volt or 4 to 20 milliamps signal. By monitoring this signal over time, your PLC logic could identify abnormal behavior, which could lead to preventative maintenance. If you have an I/O actuator with a brushed DC motor, Linac has developed an algorithm which estimates the remaining useful life. This feature can be used as a guideline for how long the actuator remains fully operational, measured in a percentage. If the actuator is brand new, it'll start with 100% remaining useful life, and this number will decrease based on the historic usage. This information can also be broadcasted as either a digital or analog signal, depending on your preferences. Since this information is very tangible, the need for advanced PLC logic could potentially be avoided. Simply set a lower limit for when to raise a flag if your application does not allow downtime. From the first time your actuator powers on, usage data is collected and stored internally throughout the actuator lifetime and can be read out from within Actuator Connect. While real-time data provides a good snapshot of a few parameters, the historical data gives you in-depth knowledge about performance over time. Like for example, here I can see that the stops due to undervoltage has occurred 6 times, which can give me an idea about the power supply's life. By analyzing this data, you can support continuous improvements after field testing or further development of existing machinery. An example could be that you collect a few actuators that are performing the same task in an application, and then you analyze the historic usage data to make a comparison. By looking at temperature and current consumption, you can also get a generalized idea of the operating environment. It's also possible to download a complete report as a PDF with general information about the actuator, type, position, last known status, etc., and comprehensive usage data that summarizes all stored historical data, including error logs, over the entire lifespan of the actuator. You can use this data to analyze the performance of one actuator or compare several actuators. The PDF also contains the actual wiring diagram and software configuration, which can be used if you want to order new actuators or simply as a starting point for a technical discussion with your local Linac contact. We hope you enjoyed this introduction to monitor features within Actuator Connect and that you can use this knowledge to think outside of the box when designing future applications. If you have any questions about Linac I/O actuators or the options that come with them, feel free to contact your local Linac office. Thanks for watching.